Ladies and gentlemen, welcome back to my channel. We are all set to enter the main line chemical bonding. It's episode 9. We start with the most basic theory in chemical bonding, that is electronic theory of chemical bonding. So how all it started? It's all started in 1916 when the worst world war was going on and the people from the world were suffering from the cause of the First World War. But the two brilliant scientists or chemists, one from the America, that is Gilbert Lewis, and one from German, Walter Kossel, they were working independently to answer two most important yet basic questions of chemical bonding. The first question was why do atoms combine? And the second question was how do atom combines? So in order to answer this question, they first look after such atoms that do not take part in chemical bonding and they are inert or they do not combine. So to their fortunate, the noble gases were already discovered in 1898. So they get to look to noble gases and examine their electronic configuration. What they found was that all the noble gas except helium have 8 electrons in their outermost shell or valence shell. Here is the electronic configuration in the form of KLMNO, and here is in the form of Sp and Df. For helium, there is no scope of containing 8 electrons because it has only one orbital. So it's a very misery for helium. Other than helium, all noble gases have 8 electrons in its outermost shell. As you can see, the electronic configuration 2, 2, 8, 2, 8, 8, 2, 8, 18, 8, 2, 8, 18, 18, 8, and this. And in SPDF, 2s to 2p6, 3s to 3p6, 4s to 4p6, 5s to 5p6, and 6s to 6p6. So they found that there are 8 electrons in all the noble gases except helium. And they know that these noble gases are inert. They do not take part in chemical reaction. So what makes this electronic configuration stable? What provides them stability if they have this type of configurations? They found that the 8 electrons, the outermost shell, are completely filled. The outermost shell of these gases are completely filled, and they are in the lowest energy states. So there is no scope for further reducing their energy level, so they are inert. And we know that chemical bonding, the energy is reduced, so but it is already in minimum energy state, so there is no scope for further reducing the energy, so they do not part in chemical reactions. So they gave a theory that the atoms combines actually to attain stability by achieving 8 electrons in their outermost orbit. Okay. Mr. Walter Kossel introduced the concept of complete transfer of electron, and Mr. Gilbert Lewis introduced the concept of shared bond electrons. So the second question is how do atom combines? Mr. Kossel said that they combine by complete transfer of electrons that pave the way for the formation of ionic bond, and Mr. Gilbert Lewis introduced the concept of shared bond electron, that is sharing of electrons, and paved the way for the formation of covalent bond. So Mr. W. Cosell said that atoms combine by complete transfer of electrons and gave the concept of ionic bond. So the concept of ionic bond is given by Mr. W. Cosell. Mr. G. Lewis or Gilbert Lewis said that atoms combine by sharing of electrons and he gave the concept of covalent bond. Further, Lewis dot structure to represent valence electrons. ठीक है, तो कोवेलेंट बॉन्ड का कंसेप्ट किसने दिया? गिलबर्ट लुइस ने. आयनिक बॉन्ड का कंसेप्ट किसने दिया? मिस्टर डब्ल्यू कॉसेल. सो कलेक्टिवली द theory given by both of them is called as electronic theory of chemical bonding. This is the most basic theory of chemical bonding and laid the foundation stone in chemical bonding. Now we will see the postulates of this theory one by one. Let's discuss the important postulates of this theory or important point of this theory. The first one is atoms combine to achieve stability by attaining noble gas configuration. Second one, atoms combine either by complete transfer of electrons or by sharing of valence electrons. The third one is only valence electron takes part in formation of bond and the kernel remains unchanged. What is kernel? Kernel is nucleus plus core electrons. So the electrons other than valence electron are called as core electrons and plus nucleus together is called kernel. So the kernel remains unchanged. The fourth one, the number of valence electrons thus involved is called valency of the atom. जितने नंबर ऑफ इलेक्ट्रॉन्स इन्वॉल्व रहेंगे केमिकल बॉन्ड फॉर्मेशन में उसी को हम लोग बोलेंगे वैलेंसी ऑफ दैट एटम. ठीक है. नाउ वी आर गोइंग टू स्टार्ट द फर्स्ट टाइप ऑफ बॉन्ड, दैट इज आयोनिक बॉन्ड. सो लेट्स स्टार्ट विथ आयोनिक बॉन्ड. Ionic bond is discovered by Walter Kossage, as I earlier said. It is also known as electrovalent bond or polar bond. It is formed by complete transfer of valence electron. Number of electron lost or gained is called as electrovalency. This bond is formed between electropositive atom, जिसको हम लोग मेटल बोलते हैं, and electronegative atom जो कि नॉन मेटल होता है. The last one is ionic bond is non-rigid and non-directional. आइए देखते हैं. लेट्स सी. एक हमने इलेक्ट्रोपॉजिटिव एटम लिया है. कौन होता है इलेक्ट्रोपॉजिटिव एटम? अ मेटल. एक हमने इलेक्ट्रोनेगेटिव एटम लिया है जो कि एक नॉन मेटल होता है. हमने बोला कि आयनिक बॉन्ड इज फॉर्म्ड बाय कंप्लीट ट्रांसफर ऑफ वैलेंस इलेक्ट्रॉन. ठीक है. दिस इज सोडियम. वैलेंस इलेक्ट्रॉन इज 1. इफ इट लॉस्ट इट्स वैलेंस इलेक्ट्रॉन, दैट इज 1 इलेक्ट्रॉन, it will gain this type of electronic configuration 1s2 2s2 2p6. That is 2s2 2p6. ये हो जाएगा हमारा. ये अगर हट जाएगा तो ये हो जाएगा हमारा आउटर शेल, वैलेंस शेल, और उसमें क्या हो जाएगा 8 इलेक्ट्रॉन्स. वी विल गेट 8 इलेक्ट्रॉन्स इन द वैलेंस शेल इफ इट लॉस्ट दिस इलेक्ट्रॉन. तो ये 3 हमारा खत्म हो जाएगा. यहाँ पे बचेगा 2s2 2p6. ये है हमारा क्लोरीन, एक इलेक्ट्रोनेगेटिव एटम. इसके वैलेंस शेल में कितने इलेक्ट्रॉन है? 7 इलेक्ट्रॉन. 1 लेस देन 8 इलेक्ट्रॉन्स. ये इलेक्ट्रॉन अगर ये गेन कर लेगा इससे तो ये हो जाएगा 3s2 3p6, ए नोबल गैस कॉन्फ़िगरेशन. तो व्हाट इज गोइंग ऑन हियर? सोडियम इज कंप्लीटली ट्रांसफर इट्स इलेक्ट्रॉन. इसको नहीं चाहिए बिकॉज आफ्टर लॉजिंग it will get a noble gas configuration, and this Cl chlorine atom will gain this electron in its outermost orbit and become 3s2 3p6, that is 8 electrons. After losing the electron, there will be a positive charge on sodium Na plus, and there will be a negative charge on chlorine atom and become an anion, a chlorine anion. So it will achieve a noble gas configuration by losing the electron, and it will achieve a noble gas configuration by gaining an electron. Sodium will become Na plus and Cl will become Cl minus. This is cation and this is anion. Which force is holding these two together is electrostatic force of attraction. ठीक है, तो ionic bond is simply a electrostatic force of attraction between opposite charge ions formed by complete transfer of valence electrons. ठीक है, please note it down so I can move further. Now let's discuss mechanism of formation of ionic bond. Ionic bond is electrostatic force of attraction between a cation and an anion. Here is cation, here is anion. Cation कौन form करेगा? Highly electropositive atom, and an anion will be formed by highly electronegative atom. Usually a metal or usually a non-metal. The atom that forms cation should have low ionization energy. An atom that will form anion should have high electron affinity. I have discussed ionization energy and electron affinity already in previous chapters. If you don't know, please refer to those chapters. We have magnesium atom, electropositive atom of metal, and we have oxygen, electronegative atom, and a non-metal. The electronic configuration of Mg, all you know, 1s2, 2s2, 2p6, 3s2, and that of oxygen is 1s2, 2s2, 2p4. It has 2 electrons in its outermost shell, or we can say it has 2 valence electrons. Mr. Oxygen have 6 electrons in its outermost shell, or we can say has valence electron 6. Mg will give up its 2 electrons to oxygen, because after losing these 2 electrons, it will gain a noble gas configuration NH2NP6 after losing this, and oxygen will have 2s2 2p4 tha. Now it will become, after gaining 2 electrons, it will become 2s2 2p6. So it becomes, after losing 2 electrons, 2 positive charge develop on magnesium and become Mg2 plus, and after gaining 2 electrons, it will become 2 minus. So we have a cation, we have an anion. There is electrostatic force of attraction that hold them together. Note it down. Let's move on to a new topic that is energy budget in ionic bond. We have in a solid half Cl2 gas and the formation of NaCl solid. One side we have energy expenditure, amount of energy we have to expense, and there is energy available, that is what amount of energy we have to expense. Na solid to Na gas. This equation is called heat of sublimation, that is transfer of solid to transfer a gaseous atom, that is change of sodium solid state to gaseous state directly is called heat of sublimation, because we have to form Na plus first and Cl minus first, then we will make a ionic bond. Na gas to Na plus gas means cation, creation of a cation. What we need? Ionization energy. We are ionizing this gaseous atom to gaseous anion. The amount of energy required to remove the electron is called ionization energy. We cannot directly remove electron from any solid. We have to convert it to gas, then remove the electron. We have already learned this in the chapter ionization energy. So we have created sodium cation, and the energy required is ionization energy. Here energy required is heat of sublimation. Further we now going to create an ion, half Cl2 gas to Cl gas. We have to dissociate Cl2. We have Cl2 like this, Cl bond. We have to break this bond to create a Cl gas. This is basically bond dissociation energy, enthalpy of dissociation. So delta heat sublimation is 108 kilojoule per mole, ionization energy is 496 kilojoule per mole, and the heat of dissociation of Cl2 half mole 121 kilojoule per mole. This is the amount of energy we require to expense. We have to give up this. This amount of energy is going to be absorbed by for the formation of ionic bond. Now move on to energy available. What type of energy are available to us to meet these expenses? So the only energy we have available to us is electron affinity. Cl gas plus electron, we have Cl minus plus electron affinity. We have already discussed in the chapter electron affinity that this is the amount of energy released. So when the energy is released, we have this energy to meet the expenses, because these energy are absorbed in the reactions. So the electron affinity is 349 kilojoule per mole. Total energy required is 725 kilojoule per mole, and the energy available is 349 kilojoule per mole. This is more than this by how much amount? The energy gap is 376 kilojoule per mole. We need this amount of energy or more than this to meet this expenditure. To where will the extra energy comes from? What are the resources we have? We must have this amount of energy or more than this to complete the reactions. So we have forget that we have created a cation and an ion. This is gas, and it will create ionic bond and forms NaCl solid. Anion, cation, there will be attraction force, that is called ionic bond between these. This lead to formation of NaCl solid. I have already told you, when there is attraction there is release of energy. So these equations release energy, जिसको हम लोग बोलते हैं, what we call it, lattice energy. We will discuss next this topic, lattice energy. Let us know what is amount. 787 kilojoule per mole. So this amount of energy is released due to attraction between Na plus and Cl minus gas. So this amount of energy will help us to meet these expenditures. What amount of energy required? 376. Subtract there. So what amount of energy we will left for? 787 minus 376 equal to 11411 kilojoule per mole. So we will left with this amount of energy. This extra amount of energy we will left with. And this is used for the formation of this. This is called heat of formation of NaCl solid, and it will be delta H formation 411 kilojoule per mole. Heat of formation, what is the definition of heat of formation? Formation of 1 mole of a compound from its constituent atom in natural state. What is the natural state of sodium? This is solid. सोडियम नेचर में कैसे पाया जाता है? सॉलिड के फॉर्म में, और Cl गैस के फॉर्म में. सो दिस विल बी heat of formation 411 kilojoule per mole. We will discuss it in detail in lattice energy and Born-Haber cycle. Note it down so that we can move further. Let's start lattice energy. Why we are studying lattice energy in ionic bond? Because ionic form led to the formation of an ionic crystal, and that requires lattice energy, because ionic crystals are in the form of lattice that stores energy in the form of lattice energy. So it is important to study lattice energy in ionic bond. So what is lattice energy? The amount of energy released during the formation of 1 mole of ionic crystal from constituent gaseous cation and gaseous anion. 1 मोल आयनिक क्रिस्टल बनाने में फ्रॉम गैसेस केटायन एंड गैसेस एनायन जो एनर्जी रिलीज होगी उसको हम लोग कहेंगे लैटिस एनर्जी. तो पॉइंट टू बी नोटेड इज दैट अंडरलाइन 1 मोल ऑफ आयनिक क्रिस्टल एंड प्लीज अंडरलाइन गैसेस केटायन एंड गैसेस एनायन. The crystal thus formed should be in 1 mole and the constituent gaseous cation and gaseous anion should be in gaseous form rather than in solid form. The other definition is the amount of energy required to break down 1 mole of an ionic crystal into its constituent gaseous cation and gaseous anion. Similarly, 1 मोल आयनिक क्रिस्टल को तोड़ने में जो एनर्जी लगेगी उसी को हम लोग क्या बोलेंगे? लैटिस एनर्जी. इट विल बी रिप्रेजेंट लाइक दिस mx solid plus lattice energy, then it will be break down into gaseous cation and gaseous anion. ठीक है. The ionic crystal should be in solid state and the constituent atom should be in cation and anion should be in gaseous state. क्वेश्चन करेंगे इसके ऊपर, कंसेप्ट के ऊपर, उसके बाद वी विल मूव फर्दर. Here is the question: which of the following is the correct representation of lattice energy? First option, Na plus solid plus Cl minus gas, NaCl solid plus lattice energy. Okay, so lattice energy रिलीज होगी, सही है. NaCl solid बनेगा, सही है. Cl minus गैस सही है. Na प्लस सॉलिड ये गलत है. यहाँ पे क्या होगा? गैस फॉर्म में. सेकंड ऑप्शन, Na प्लस गैस सही है, Cl माइनस गैस सही है. NaCl गैस गलत है. मैंने बोला कि सॉलिड होना चाहिए. दिस शुड बी ए सॉलिड. लैटिस एनर्जी रिलीज होगी. ठीक है. थर्ड ऑप्शन सही है, गैस है सही है, सॉलिड है सही है, लैटिस एनर्जी रिलीज होगी, सही है. फोर्थ ऑप्शन, NaCl सॉलिड टर्न इनटू Na प्लस गैस सही है, Cl माइनस गैस सही है. ये एनर्जी रिलीज नहीं होगी, यहाँ पे एब्जॉर्ब होगी. एनर्जी आपको देनी पड़ेगी. ये आएगा इस तरफ, तो ये गलत, ये गलत, ये गलत, ये सही है. नेक्स्ट ऑप्शन, NaCl सॉलिड सही है, प्लस लैटिस एनर्जी देना पड़ेगी, सही है. Na प्लस गैस, Cl माइनस गैस, ठीक है. दिस इज ऑल्सो करेक्ट. सो दिस टू रिप्रेजेंटेशन इज करेक्ट and the rest of 3 is wrong. Note it down. Let's move to the new topic that is calculation of lattice energy. The first way of calculating lattice energy is Born-Landé equation. It considered bonds as complete ionic in nature. That the bonds are 100% ionic. He considers and it's give a theoretical value of this. So simply considering force of attraction that is k z e square on 4 pi z plus z minus. ठीक है. So what he considered? He considered there is force of attraction that is releases energy. The formula is U represents lattice energy is equal to minus Na क्या हमारा अवोगाड्रो नंबर, M है मेडलैंग कांस्टेंट. मेडलैंग कांस्टेंट डिपेंड करता है ज्योमेट्री या अरेंजमेंट ऑफ आयंस इन क्रिस्टल लैटिस. Z plus and Z minus are numerical value of charge. For example, if you have MgO lattice, Z प्लस का वैल्यू हो जाएगा 2 एंड Z माइनस का वैल्यू हो जाएगा 2. चार्ज कितना है Mg पे +2, O पे है -2. Z प्लस का वैल्यू 2 एंड Z माइनस का वैल्यू भी 2. E क्या हमारा इलेक्ट्रॉनिक चार्ज, इसका वैल्यू कितना 1.6 इंटू 10⁻⁻19. तो चार्ज होता है इलेक्ट्रॉन पे बाई 4 पाई एप्सिलॉन. एक कांस्टेंट वैल्यू है, ब्रैकेट में है 1 - 1/n. n क्या हमारा बॉन्ड एक्सपोनेंट, इसको हम लोग बोलते हैं शॉर्ट रेंज रिपल्शन बिटवीन इलेक्ट्रॉन्स. ये क्या है रिपल्शन फैक्टर. और ये क्या है यहाँ से यहाँ तक अट्रैक्शन फैक्टर. जब इसको आप गुना करोगे ब्रैकेट से, व्हेन यू मल्टीप्लाई दिस टू द ब्रैकेट इट विल बिकम माइनस एंड ये माइनस माइनस प्लस, दिस विल बिकम रिपल्शन फैक्टर. So what he applies, he considered the attraction forces and the repulsion forces and subtracts them, so the net attraction give us the lattice energy. Note it down. Now let us move to the second method of calculation of lattice energy. The second one is Bohr-Haber cycle. It is actually a cycle, you can say it. In a solid plus half Cl2 gas, heat of formation NaCl solid. I have already told you in a solid heat of formation is defined as the amount of heat released during the formation of NaCl solid from its constituent atoms in natural state. So the constituent atom should be in natural state. Sodium's natural state is solid, chlorine's natural state is gas. ठीक है. So the amount of energy released will be heat of formation of NaCl. In a solid, heat of sublimation given becomes in a gas, then ionization energy given would become ionized to cation Na plus gas, Cl2 dissociation energy, Cl gas, then one electron is removed from Cl, becomes Cl minus, amount of energy called as electron affinity or electron gain enthalpy. We will get a sodium cation and chlorine anion. When you add this, you will get NaCl solid, and this is what we call lattice energy. Remember the definition of lattice energy: when 1 mole of a ionic crystal formed from constituent gaseous cation and gaseous anion, the amount of energy released is called lattice energy. Note it down, then we will discuss it in details. Now let's discuss the cycle. ये हमारा प्राइमरी रिएक्शन था, Na solid हाफ Cl2 गैस NaCl, इसको मैंने बोला हीट ऑफ फॉर्मेशन ऑफ NaCl. सारा जितना मैंने साइकिल बनाया था सबको मैंने इक्वेशन वाइज रिप्रेजेंट कर दिया है. पहला था Na solids प्लस हीट ऑफ सब्लिमेशन Na गैस, देन Na गैस प्लस आयनाइजेशन एनर्जी Na प्लस गैस, एक इलेक्ट्रॉन निकला, हाफ Cl2 गैस प्लस हीट ऑफ डिसोसिएशन Cl गैस प्लस इलेक्ट्रॉन Cl माइनस एनायन बना प्लस इलेक्ट्रॉन एफिनिटी रिलीज हुई. फिर अब लास्ट में क्या था हमारा Na प्लस गैस प्लस Cl माइनस गैस NaCl सॉलिड, और ये क्या निकला हमारा लैटिस एनर्जी. यही हमको निकालना है. वी हैव टू फाइंड आउट दिस लैटिस एनर्जी फ्रॉम दिस इक्वेशंस. मैंने जब सारे इक्वेशन को ऐड किया, ठीक है, Na solid, Na gas strike out, Na plus strike out, Cl minus strike out. After striking everything out, we will have get Na solid plus half Cl2 gas, NaCl solid. ये फाइनल इक्वेशन हमको मिलेगा सब कुछ सब्सट्रैक्ट करने के बाद, ठीक है। अब याद कीजिए हेसेस लॉ ऑफ कांस्टेंट हीट समेशन, पहले बता चुका हूँ। व्हाट इज हेसेस लॉ ऑफ कांस्टेंट हीट समेशन? द एंथैल्पी चेंज फॉर ए रिएक्शन रिमेन्स सेम वेदर द रिएक्शन टेक्स प्लेस इन वन स्टेप और इन सेवरल स्टेप्स, ठीक है। ये एक वन स्टेप रिएक्शन है। एंथैल्पी चेंज क्या है? डेल्टा हीट ऑफ फॉर्मेशन, और ये नंबर ऑफ स्टेप्स दैट लीड्स टू द सेम इक्वेशन दिस, ठीक है। अब इसकी एंथैल्पी चेंज निकाल देंगे और इसके बराबर कर देंगे, ठीक है। कैलकुलेट द एंथैल्पी चेंज फ्रॉम दिस इक्वेशंस एंड मेक इट इक्वल टू डेल्टा एच एफ। ओके, द एंथैल्पी चेंज फॉर दिस रिएक्शन, हाउ टू कैलकुलेट? Add right hand side and subtract it left hand side. That is what is enthalpy change. Enthalpy change क्या होता है for a reaction, ठीक है। Heat from the right side minus heat from the left side, or energy on the right side minus energy on the left side. Right side में क्या क्या हमारे पास है? We have लैटिस एनर्जी एंड इलेक्ट्रॉन एफिनिटी माइनस ऑन लेफ्ट साइड में क्या है? डेल्टा एच एस आयोनाइजेशन एनर्जी एंड डेल्टा एच डिसोसिएशन, ठीक है। राइट साइड वाले में से लेफ्ट साइड को माइनस करेंगे तो हमको इस रिएक्शन की एंथैल्पी चेंज मिलेगी। दैट शुड बी इक्वल टू हीट ऑफ फॉर्मेशन एज पर हेसेस लॉ ऑफ कांस्टेंट हीट समेशन। डेल्टा एच एफ आपको दिया हुआ है 411 किलो जूल पर मोल। लैटिस एनर्जी कितनी है निकालनी है? इलेक्ट्रॉन एफिनिटी है 349, हीट ऑफ सब्लिमेशन 108, हीट ऑफ डिसोसिएशन 121 एंड आयोनाइजेशन एनर्जी ऑफ आयोनाइजेशन 196। आफ्टर कैलकुलेटिंग दिस U इज इक्वल टू 411 माइनस, इधर आएगा तो माइनस में आएगा 349, और ये पूरा क्या हो जाएगा? माइनस में है तो इधर आएगा तो प्लस में। इन तीनों को ऐड करेंगे, वी विल गेट 725 एंड फाइनली वी विल गेट U इज इक्वल टू 3786 किलो जूल पर मोल, ठीक है। इस तरह से हम लोग निकालेंगे क्या? लैटिस एनर्जी, ठीक है। इसको हम लोग बोलते हैं, ये जो टेक्निक है निकालने की फ्रॉम बॉर्न हैबर साइकिल, इसको बोलते हैं हम लोग एक्सपेरिमेंटल वैल्यू, याद रखेंगे। इसको बोलते हैं हम लोग एक्सपेरिमेंटल वैल्यू, ठीक है। बिकॉज इट अकाउंट्स नॉट ओनली आयनिक बॉन्ड बट ऑल्सो द कोवेलेंट नेचर इन द सेड बॉन्ड। ये आयनिक कंसीडर नहीं कंसीडर करता, सिर्फ कोवेलेंट बॉन्ड भी कंसीडर करता है। तो ये प्योरली आयनिक बॉन्ड नहीं मानता है, जो भी कैरेक्टर होगा कोवेलेंट कैरेक्टर भी होगा तो उसको भी कंसीडर करेगा। तो लैटिस एनर्जी दैट कम्स फ्रॉम बॉर्न हैबर साइकिल ऑलवेज ग्रेटर देन दैट कम्स फ्रॉम बॉर्न लैंडे इक्वेशन, ठीक है। जो लैटिस एनर्जी यहाँ से निकलेगी ये हमेशा उनसे ज़्यादा होगी, क्योंकि इसमें कोवेलेंट नेचर भी रहेगा जो इम्पार्ट करेगा सम मोर स्ट्रेंथ। सो आयनिक बॉन्ड स्ट्रेंथ प्लस कोवेलेंट बॉन्ड कैरेक्टर स्ट्रेंथ add to the lattice energy, so this will always be greater than what calculated from the Born-Lande equation. तो बॉर्न हैबर साइकिल से निकालने के लिए क्या क्या जरूरत पड़ेगी अपने को? हेसेस लॉ ऑफ कांस्टेंट हीट समेशन, हीट ऑफ फॉर्मेशन ऑफ NaCl सॉलिड एंड दिस simple equations because it's form a cycle. Note it down. In the next episode, we will discuss some factors affecting lattice energy and then hydration energy then process of dissolution यानी solubility. Thank you.